So we're going to um, run through, three of us are going to cover the content here from BIM, from Autodesk side. And with that, I'm going to hand over to Harlan Broom, who's the Revit product manager. Hey, Harlan.
Hey, thanks everybody. It's great to be here virtually with all of you, and I hope this is interesting. So Pete, next slide. So today we're going to break this down really into 4 sections. We're going to talk about design, talk a little bit about building information modeling, how the growth of BIM is changing things in the design world. We'll talk about evaluation and how you can actually leverage building information modeling for analysis. We'll talk about optimization. How do you repeat that analysis to create better designs and better optioneering, and how do you leverage that for the future? And then we'll talk about the future and next-gen opportunities. So starting with design, I'll talk a little bit here about what is BIM. Some of you may be familiar with the concept of what is BIM, what is building information modeling in general. This is kind of our standard definition of what this is all about. The important thing that I want to call your attention to here is really that it's a process. It's not simply the act of creating a model. It is a process of actually collaboration and building insights into the built environment, so that you can actually efficiently plan, design, construct, and then eventually manage the entire building and infrastructure projects. So, it's not just a fancy name for we're going to create a 3D model. It's actually all about the information and the process that goes into, things like understanding collisions and coordination between different projects. Next slide, Pete. So this is a graph. It's a couple of years old now, and it we wanted to show this to give you an understanding of kind of the public perception of where things are with the current use of building information modeling in the industry. I think this is like 3 or 4 maybe years old now, and some of the numbers have changed, but it was a prediction based on current adoption. The lowest bar in these studies, like in the UK, 46% had adopted, and then their predictions on how fast they would grow adoption. In particular, in the UK, things have changed a little bit recently. They're saying that adoption has slowed, and they're looking at why some of that has happened. But these trends have been, seen kind of across the world, no matter where they are, and we continue to see a lot of uptick in this. And one of the biggest drivers here is around mandates. In particular, like in the UK, there's been mandates that have driven for all public projects. They're going to use BIM and different levels of maturity of BIM as they try to strive to become more and more digital and more aware of the level of detail and the level of collaboration they're providing on projects. Next slide, Pete. And again, though, it's not about just creating drawings, which is kind of the thing that everybody has to still do today, but it's actually really about the importance of the data and the ability to actually understand everything there is about the elements inside that model, being able to schedule the information, being able to actually parse it in a way that's not just looking at a model or drawings, actually diving in and really getting a deep understanding of how things are going to be built based on the actual data that's available within the project. And we see this, kind of the converse of the typical drawing-based method of doing this. Why people are really going to BIM is the amount of information that they gather from the projects that they have, and really what I like to call the ability for them to practice. They build the building virtually. They get all this great information. They can make better design decisions and have better collaboration with all the different stakeholders on the project to efficiently deliver a successful building that's hopefully on time and under budget and all the things that are important in this industry. And next slide. So now let's talk a little bit about why we're seeing more and more use of kind of general analysis with these models. You create these great models, you have documentation, you have the data, but we're finding there's a lot of opportunity in the space for analysis as well. Next. All right. So one of the things that we've introduced in Revit in particular in our latest release is what we call path of travel. And this is really a simulation tool designed so that someone very simply can choose a point A or to a point B in their model and understand how the person would move along that path. It's designed to take the shortest path between those 2 points. Because we're using this in a model-based workflow, we understand that there's obstacles, there's doors in the way, there's furniture perhaps that you need to be able to navigate around, and we can actually take that all into consideration and really quickly create that path. It allows for simple analysis of like height zones. So if you need to be able to go through a threshold or underneath a stair, you can understand that. And because it's all based on building information model and data that's here, Pete, there's something on your screen. Sorry. You can actually schedule this information as well. So you can understand the length of these paths. You can understand the time it takes based on an average walking speed to be able to move between those 2 points in the model. You can add additional parameters and information to do calculations or to really understand how people move. And you can do things like instantly color coding these paths based on that information. So if something's over a specific distance, or if you're looking to make sure you understand how fast people can get out, you can all do that graphically in the view as well, but it's all based on the data. Next slide, Pete. So this is a little video showing this in motion right now in Revit 2020. Basically 2D, like I said, it's pretty simple. We added a button called Path of Travel. You pick the 2 points, it routes the person along the path. And it gives you the ability to customize things like obstacles and the analysis. It gives you the ability to update these paths. If there are design changes along the way, someone moves a wall, you need to understand, well, actually, I'm not going through this stair in this example, where you can actually see, like, okay, I want to make sure that my head clearance is correct and that I'm not being, someone could actually walk underneath that. And it's analyzing, that route between those 2 points in a dynamic and kind of up-to-date way. And this is just showing some of the filtering capability that we have, the ability to kind of change the line weight, change the graphical standard, because it's obviously important in a lot of these cases, to do kind of simple analysis just on that 2D plan. And here's showing the kind of update workflow, making design changes dynamically inside the model, adding walls, adding doors, and then updating that path to reflect those design changes. Next slide, Pete. So just wanted to give you guys another highlight of what that's capable of doing. Pretty quickly, you can evaluate these distances and the times in the model across multiple spaces, multiple parts of the model to multiple exits, and create these kind of diagrams based on the model geometry itself. Next slide, Pete.
So leading on from Harlan's great grounding and introduction, and going a little bit more into some of the aspects of analysis that can be launched from the BIM platform. So, for example, one of the teams I'm involved with is the Insight Energy Analysis, which allows the user to look at the thermal properties of the spaces and then do their heat and ventilation, air conditioning analysis and their energy performance model. It uses spaces and material properties, and much of that could potentially also be used for fire safety analysis as well. And that's really one of the optimization pathways, which we're allowing people to optimize the energy performance of their building with cloud services. Additionally, you can also do structural analysis launched from the BIM platform as well, looking at the wireframe analysis of the structural interrelationships of the model, and allows you to size your beams and your columns, etc., through various plastic and elastic deformation processes. And again, there's these properties could potentially be used for structural analysis in fire safety areas too. And also at the moment, it's important to realize that different fire safety engineering related software packages are starting to leverage the BIM platform. So I've got some screenshots here from Pathfinder and Building Exodus as well, where they've imported the IFC model, which Angel will talk to shortly. And also there are elements like add-ins or direct plugins to Revit, which you can use to directly drive the functionality of the BIM model within the package itself by customizing it. So with that, Angel, I'm going to pass over to you.
Right. Thanks, Pete. So I'm just going to talk about IFCs a little bit. So as Pete mentioned, many BIM-based programs, such as Revit, have API that allow third parties to directly access native data for further processing. This allows for a great deal of openness and access to the data, but requires creating and maintaining one-to-one connections between programs, which can be prohibitively expensive, especially for smaller vendors. In 1994, 25 years ago, Autodesk, in conjunction with an industry consortium of 12 initial companies, formed the Industry Alliance for Interoperability, which later became the International Alliance for Interoperability and finally became BuildingSmart, for the purpose of making a neutral, open format for the exchange of BIM data across products. This became the Industry Foundation Classes, or IFC, file format, which you can kind of see there in the second row on the left-hand side. Now, a valid IFC file has two important components defining it: a file schema and a model view definition, or an MVD. If you've ever heard the terms IFC 2x3 or IFC 4, these refer to the schema, which represents kind of the collection of entities that define the possible extent of representable IFC data. To narrow this down, the MVD specifies a subset of the schema that corresponds to the actual user workflow. The image on the right represents some of the workflows that IFC was traditionally designed to access and address. Next slide, please. So over time, though, IFCs and their corresponding MVDs have expanded to reach adjacent industries. So the top 5 MVDs above all represent, for either IFC 2x3 or IFC 4, some of the traditional areas where IFC has had the greatest impact. Furthermore, there's active work going on in the infrastructure domain for both kind of IFC 4.x and IFC 5, including IFC MVDs for roads, bridges, and tunnels, among other similar things. Of more interest to this group, however, is the recently proposed MVD that would cover fire safety engineering, and that's the one at the bottom. Because this is still in the early stages, there is still an opportunity for all of you to get involved in fine-tuning the workflow behind this MVD, and to also encourage software vendors that create the products that you use to implement it once it has been finalized. So with that, I'll pass that back to Pete.
Thanks, Angel. So we're seeing the process of fire safety engineering world starting to utilize the BIM models more directly. So that process starts with the digital building model in the BIM package. Some of the occupant movement simulation packages are starting to leverage IFC files, and there are one or two with add-ins to BIM packages. And then you can start to visualize people flows or distributions of temperatures within the spaces using BIM platforms' own built-in visualization tools. So what you see on the right, there's an analysis visual framework. So if you choose to, you can put this data back on the BIM model itself directly and visualize the results. Taking this process and integrating it with the BIM model preserves the golden thread of information, which is the term, where we try and maintain consistency of data, iterative checks as the design changes, and also future enhancements as well. So utilizing the IFC files, you can use your model view definition, which is this version of the IFC, to check your model, store relevant data. It could be used for airports, high-rise stadia, etc., etc. You can export the model, analyze your results, and import the results back onto the BIM model. And that's an important process to involve the whole design team, so there's a consistent set of data on the way through, really through the design, construction, and operation phases. So leading on from there and looking at optimization pathways, I'm not going to spend too long on this, but there is application programmable interfaces, you call it API, which Revit has. So you have the Revit main software, has a layer here called the API, and third-party developers can develop their own individual analysis applications to plug into that data and functionality. And you can add your own button on the toolbar to host your own little customized version of the package and analyze, quantify, and use that data. This short video is a quick demonstration of the use of the API. So someone's using the path of travel function here. They've written a custom script using the open source Dynamo package. Allows you to create customized scripts to call inbuilt features. And here the user is choosing 2 exits and automating the running of the path of travel script, really to find, so this is the second exit being chosen, and then they're really trying to find the most remote point from those 2 doorways, and it scans all the spaces in the building, it finds the most remote point, and then uses the path of travel analysis to plot the route out, and it highlights it in red if it exceeds the maximum travel distance available. And then you can tag that. It automatically dimensions it like a dimension line, both in terms of distance and walking time, using average walking speed. And then you can also take a look at the visual programming language behind it. So if people don't want to get deep into the scripted code, you can actually look at this visual programming language, which allows you to build up the blocks of logic to start commanding the BIM package. And this is an increasingly popular way of accessing the sort of digital design and the BIM package itself. And just a couple of notes at the end. I also am a visiting lecturer at University of Lund, and we've had a couple of master's projects which have looked at using the BIM data for fire safety engineering analysis. So Sylvia wrote her own scripting tool to bring the data from Revit into PyroSim, and then on again from PyroSim into FDS. Some of the material data was missing in that data transport process, which she fixed with a side script, and got very good results in terms of looking at the compartment fire modeling, and it worked. It was quite successful. In addition, Christiana looked at looking at evacuation analysis using Simulex, again using the built-in export from Revit, and then also using a new model for movement, which he developed as well to test out, and ultimately running some test situations of people going through a unit test and checking the results for a young population, an elderly population, and checking those against real world experiments and seeing how the data stacks up. And the flow rates are really quite comparable, which is encouraging so far. And we'll be publishing this work over the next 7 or 8 months. And just finally, looking at the overall future direction for Revit, really, because it's a great data platform for team working and analysis, we're looking to implement very high degrees of accuracy and detail going forward, really to make sure that data is then optimized by enabling lots of analysis, simulations, and iterations of the process, and then also allowing multidisciplinary teams to connect to a cloud-hosted central model, and then allow the design to iterate through all phases of the project lifecycle as the design team connects and shares data on a pretty much a live basis. So you end up with, right from stage 1, the design starts, to using the BIM 360 sharing of the model, so that even the construction teams on site, when they go out with their kind of rugged tablets on site, they'll look at the latest design as they build the model. And that's everything.